Okay, this video is going to start with number 28, and here it is. I've actually already done this video twice, and my video keeps cutting out on me, and I just lose everything I did, so I'm just going to put all the work up here and show you what I've done. So if you haven't read number 28, go ahead and read it. Okay, so on 28, your initial velocity is 15, your final velocity is 25. You travel a distance of 125 meters, and so your initial position is 0. Doesn't say anything about it, so count it as 0. And they're asking us to find time. The problem with what they gave us is we cannot find time without knowing acceleration. So we're going to have to use this third equation, and a lot of students shy away from this third equation because it looks rather difficult, but it is really not as difficult as it looks. So here's the equation, and because x naught is 0, I can really just take that out. So it really becomes this. Vx squared equals Vx naught squared plus 2ax. Now since I'm looking for acceleration so that I can turn around and go get time, I want to get this segment by itself. So I subtract Vx naught squared from both sides, and then I get Vx squared minus Vx naught squared equals 2ax. And then I divide both sides by 2 and by x, so it cancels out the 2 and x, and over here I end up with 2 and x on the bottom. Okay? So to show my work for that, it looks like this. I have parentheses open, 25 squared minus 15 squared, parentheses closed, and then meters squared over seconds squared. Just like when we did Vx minus Vx naught, but this time it's all squared. Okay? And you cannot put parentheses open, 25 minus 15, parentheses closed, and then put a squared on the outside of the parentheses. It will not work. So just FYI. And then, so that gets its own apartment. The 2 gets its own apartment, and it's downstairs, because it's downstairs in the equation. And the x gets its own apartment, and it's downstairs. So when I plug all this into my calculator, let's look at that real quick. So I have parentheses open, 25 squared minus 15 squared, parentheses closed, and I'm going to hit divided by 2, but watch very closely what I do next. I don't hit times 125, because if I did, it would pop 25 up to the top. So I'm going to hit divided by 125. And enter, and I get 1.6 meters per second squared. Hitting divided by twice. Okay? If you do want to hit times, then you would have to put an extra set of parentheses. So you would say, I'm going to divide all of this by the answer to this. You have to have an extra set of parentheses. So I get my acceleration, wrote it over here. Now I'm going to move on to another equation so that I can get time and rearrange for time. Okay, so it's in this segment, so I want to get the segment by itself. So subtract Vx naught from both sides, and then divide both sides by a. Okay, so plugging in my work, I have parentheses open, 25 minus 15, parentheses closed, and I've factored out the meters and the seconds. Okay, or I could have just done this in my head and just put 10 meters per second here. Okay, divided by acceleration, so that's 1.6 meters. And then the s squared is on the bottom, but I said no fractions above or below the main line, so remember if it's on the bottom, it goes to the top. So when I plug all of this in, I get 6.25 seconds. Okay, we're done. But if you want to know a shortcut, okay, for those of you who would like to know a shortcut, I can take a look at equation 1, which is this, and here's what I can do with it. Okay. X naught is 0, so that's gone. And if I can figure out what the average velocity is, which would be a little more than the initial but a little less than the final, right? The average. If I could put the average velocity here, then I could pretend that there's no acceleration. And this works because it has a uniform acceleration. Okay, so that means half the time I'm going slower than the average, and half the time I'm going more than the average. So to figure out the average, just like I would figure out your grade if you had 2 grades, I would just add them together and divide by 2 to get the average. Okay? You just add the 2 velocities together. I just factored out the units, but 15 plus 25 divided by 2. You add your initial and your final, divide by 2, and that will give you the average. Okay, now that I have the average velocity, here's what I did. I used that same equation. Let me rewrite it up here. I'm going to do this again. X equals, x naught is 0, so I'm just going to leave it away. This is equation 2. So x naught is 0, so I'm not even going to write it, equals v times t, as in the average velocity times time. So I'm also going to leave off the plus 1/2 at squared, because if I'm using the average, I can pretend there's no acceleration. Okay? So now I'm looking for time, so t would be x divided by v, and I'll go ahead and move it down here. Here's my x, here's my v. X divided by v. Seconds on the bottom, go to the top. I still get the same answer. Okay, you don't have to do it that way, but it's just a little quick shortcut trick to doing something without knowing the acceleration. As long as you know the initial velocity, final velocity, you can get the average velocity if you have a uniform acceleration. Okay, watch the next video if you need to.